The technology that could have ended range anxiety didn't fail on the road. It died quietly in a lab drawer. Not because it didn't work, not because it wasn't promising, but because no one was ready to pay for the future it unlocked. And the cost of that decision is still with us today. This is the series where we explore the futures that almost were, and the decisions that erased them. Long before electric cars became a cultural flashpoint, before charging stations and government targets and billion-dollar battery factories, engineers were already chasing the real breakthrough. Not incremental improvements, not better packaging, but a fundamentally different kind of battery. One that was safer, lighter, denser, and capable of delivering the one thing electric vehicles lacked most: confidence. Inside research labs in the 1970s, 80s, and early 90s, scientists were already working on what we now call solid-state batteries. The idea was deceptively simple: replace the liquid electrolyte, flammable, fragile, limiting, with a solid material that could safely carry ions between electrodes. On paper, the advantages were overwhelming. Solid electrolytes could enable much higher energy density. They reduced the risk of fires. They allowed new electrode materials that liquid systems couldn't tolerate. In theory, they could double range while cutting weight. Range anxiety, the psychological barrier that haunted every electric vehicle, had a solution, and the people closest to the technology knew it. Early prototypes showed promise. Lab cells demonstrated energy densities that today's lithium-ion packs would struggle to match even decades later. Researchers published papers describing stable cycling, safer chemistries, and architectures that hinted at mass market viability. But there was a problem no datasheet could solve. They were hard to make. Solid electrolytes cracked. Interfaces degraded. Manufacturing tolerances were unforgiving. Scaling from a coin cell in a lab to a battery pack in a car required precision that factories at the time simply didn't have. And that's where fear entered the room. Automakers looked at the technology and saw risk. Not just technical risk, but systemic risk. Entire production lines would need to change. Supply chains would need to be rebuilt. Decades of expertise in liquid batteries would be devalued overnight. Investors saw something worse: time. Solid-state batteries promised a future that was too far away. 10 years, maybe more. And venture capital doesn't wait for decades. Neither do quarterly earnings. Neither do companies built on existing products that still sold well. So the questions changed. Not does this solve the problem, but can we ship it next cycle? The answer at the time was no. And so funding slowed. Programs were shelved. Research groups were downsized or redirected. Not killed outright, just starved. This is the part of the story that's easy to miss. There was no single rejection, no dramatic announcement that solid-state batteries were dead. Instead, there were 1,000 small decisions. A grant not renewed, a pilot line never built, a prototype deemed not yet commercially relevant. The technology slipped into the future tense. Meanwhile, lithium-ion batteries kept improving. Slowly, predictably, incrementally, energy density climbed year by year, costs fell, manufacturing scaled, and most importantly, companies learned how to make them reliably at enormous volumes. Lithium-ion wasn't perfect, but it was ready, so the industry made a trade. Instead of betting on a disruptive leap, it chose continuous improvement. Instead of rebuilding factories, it optimized them. Instead of waiting for a breakthrough, it managed around the limitations. Range anxiety didn't disappear. It was tolerated. Electric vehicles became viable, but compromised. Heavy battery packs, long charge times, thermal management systems designed to prevent fires rather than enable performance. Cars that worked, but only if you planned around them. And every time a driver checked a charging app or recalculated a route, they were living inside the cost of a decision made decades earlier. The solid-state pioneers watched this unfold with frustration. They knew the ceiling lithium-ion would eventually hit. They knew safety margins were thin. They knew energy density gains would slow, but knowing the future doesn't guarantee you get to build it, because timing matters as much as truth. In the 1990s and early 2000s, electric vehicles themselves were already seen as risky. Infrastructure was lacking. Consumer demand was uncertain. Oil was cheap. Automakers were under pressure to protect existing revenue, not undermine it. Betting on a radically new battery technology on top of an already controversial drivetrain felt reckless. So automakers walked away. Investors followed, and the future waited. It waited while internal combustion engines became more efficient. It waited while hybrids bridged the gap. It waited while entire generations grew up thinking electric cars were niche experiments. Then something shifted. Climate targets hardened. Cities pushed back on emissions. And suddenly, range anxiety wasn't an inconvenience. It was a barrier to adoption at global scale. Only then did the industry turn back to the drawer. The same solid-state concepts, the same promises, the same papers, dusted off and rebranded. But now the problem looked different. Manufacturing had advanced. Precision had improved. Materials science had matured. And perhaps most importantly, the industry had run out of room to hide. Incremental gains were no longer enough. The irony is painful. The technology that could have accelerated the electric transition by decades was always there. Not hidden, not secret, just inconvenient. It demanded patience. It demanded long-term thinking. It demanded investment without immediate payoff. And those are the exact things modern industrial systems struggle to provide. So instead, the world took the long way around. Heavier batteries, more charging stations, bigger packs to compensate for limitations that were never truly solved. And every year of delay compounded the cost, economically, environmentally, and psychologically. This story isn't just about batteries. It's about how the future gets filtered, not by what's possible, but by what's fundable. Not by what works best, but by what fits existing systems. The solid-state battery wasn't rejected because it failed. It was rejected because it asked for too much belief, too early, and somewhere in another corner of automotive history, another electric future met the same fate. A car that worked, a system that proved the concept, and a decision to walk away before the consequences were understood, because the hardest breakthroughs aren't the ones that don't work. They're the ones that work, before the world is ready to change. And somewhere right now, in another lab, another drawer is being closed.